Hi. What I want to talk about today is estimating wood floor framing systems. Um, we talked a little bit the other day about the joists and room joists. I'm going to just quickly hit on those and then jump into sheeting and nails, adhesives, and things like that. So just as we remember here, as a quick reminder, we have our joist in this in this layout here, which are actually showed as in this example, they're showed as floor trussed. We're going to have our sheeting, which is going to be running perpendicular to the joist. We're going to have a rim board that's going to go around the perimeter. Uh, and we're going to have some sort of beam. In this case here, it's shown as a flush beam with joist hangers. Another blow up example of that of what we're estimating. So we're going to be picking we're going to be estimating and taking off the rafters, the rim boards, the sheeting, and then the related adhesive and nails and fasteners. Just to kind of refresh, we're going to do we will have some blocking and bridging that we'll figure on too, which are these diagonal cross bracings here, which they could be metal. They could also be an actual diagonal pieces of wood, or it could actually be blocks of leftover lumber that's on site. We could be doing conventional lumber, which is like in the last slide, or we could be doing TGIs, which are these manufactured or engineered joists. It's another example of the TGI. Two different beams. One beam is a flush beam, and the other one is a drop beam. If we have a flush beam, we're going to cut our joist to exactly the size. We're going to put these joist hangers on. If it's a drop beamed, our rafters are going to just go right over that. Our joists are going to go right over that. This is the copy of the spreadsheet. I do have this in Blackboard now if you want to use it as a reference. And I do have kind of the cheat sheet formulas on the right side, which is basically saying what it is that we're figuring out, and which I will be going through in this lecture. So when we're figuring out our floor framing, we want to figure out, we're going to do a takeoff for our rim board, for our floor joist, the length of our for our floor joist. So we have to figure out the quantity and we have to figure out the length. If we have any joist hangers, we have to figure those. We're going to have nails for framing. We're going to have bridging. We're going to have floor sheeting, which is we're going to figure out in sheets. We're going to figure out adhesive and then nails for the sheeting. So this example here, this 28 by 24 foot little basement, we're going to figure out the flooring for that. So our first step is to figure out our rim board. And our rim board is just the perimeter around the building. And we figure that out in a lineal footage. So in this example here, it's a 28 foot by 24 foot rectangle. So basically add up those four sides, that comes up to 104 feet. So our rim board is going to be 104 feet. The next thing we want to do is figure out our joist quantity and our joist length. This example here, our joists are 16 inches on center. So how we do that is we figure the length of the wall where the joists are bearing. So in this case, it's 28 foot. We're going to divide that by 16 inches because it's 16 inches on center. And that gives us 21 spaces. But since we've already figured out our rim boards, we've already got our our rim boards already figured out. So we have the spaces that we have here are the cavities between the joist, which means that there's actually one less. So there's 20 joists that we have figured for that, because we are starting with a space, and then we're ending with a space because we've already picked out our rim boards. Okay, So yeah, we have 20 joists. Now we figure out our lengths. So in this example here, we're using the I-joist. So they're going to be one continuous rafter that goes all the way through. So in this case here, the length of the joist are 24 feet. So what we have is we have a total of, we have 20 joists that are 24 foot long. In this case here, they're 10-inch TJIs. So we've got 20 24 foot 10-inch TJIs. Okay, so we figured out the rim board. Now I take that back. We figured out the I-joist. Now we want to do this for conventional framing. So for this example here, what I did was I just set this beam offset right now just for this example. So I've got one joist space is 11 foot and the other joist space is 13 foot. And we're going to go with conventional framing on this, so we can't clear span that whole 24 foot distance. So our joists here, these are these 2x10s, and then they're going to bear on that center beam. And you notice I have them extending a little bit further. I will show that to you in a second. So basically what we have, since we're going with conventional lumber only comes in 2 foot increments. So I can get it in 8 foot, 10 foot, 12 foot, 14 foot, 16 foot long pieces. So in this example here, the span is 11 feet. So we would have to go, that span is 11 feet. So the closest lumber that we have that would fit would be a 12 foot joist. So these joists here are going to be 12 foot joists. And what we're going to do is over the beam, we're just going to overlap that joist. Now, if it was a flush beam, then we would just cut the joist to fit in between exactly to size. Now our joist 2, those are still 2x10, 16 inches on center. Now in this example, the clear span is 13 feet. So we've got a 13 foot span. We have to go with 14 foot joists are going to be the closest joists that are going to fit that span. So in this example here, again, we're going to have, this is the same example where we have our 20 joists. So we're going to have 20, we have 20 joists that are 2x10s at 12 foot, and we have 20 joists that are 2x10s at 14 foot long. I wanted to go back to this slide real quick because now we're going to do some of the accessories like the caulking, that adhesive that we're going to put on top of each member, and then we're also going to do our sheeting. So our sheeting is going to typically go perpendicular to the direction of our joist, and that's just going to give it extra strength. So the sheeting themselves, they're 4x8 sheet sizes. They're going to go perpendicular to joist, like I just said. So in this example here, what we're going to do is we're going to take the area of the floor and we're going to divide it by the area of the sheets. In this example here, this is 28 by 24 foot slab or floor. It's 672 square feet. So we're going to divide that by 32, which comes up to 21 sheets. And we would always round up to the next whole number whenever we're doing our sheets. What we also want to figure is we want to figure that that we're going to figure a 5% overage. Also, if there's like a hole in the floor, like let's say for a stairway, typically we would still include that in. So if this footprint was 672 feet, and then let's say we had a 8 foot by 4 foot opening in the floor where the stairway went through, we would still count that as part of our square footage, so we would not take that out. And then yeah, we do want to add 5% of the total. So in this example here, we've got 21 sheets. 5% is 1.05 sheets. So again, we're going to, even though it's barely over, it's over. So we're just going to round that up to the next number, which is 2 sheets. So in this example here, we'd have 23 sheets of plywood. Again, our sheets are going perpendicular, and we would kind of stagger them too. So we would start in a corner with a sheet, and if we do have a cutoff on the other side, we'll take it and we'll start the second row with it. So we do have our blocking I kind of went over that a little bit earlier, but that's going to be basically in between each span. So these are all the accessories that we have that we also have to figure out. So we want to figure out our nails for our framing. So when I say framing nails, I'm talking about framing our joist. And we're going to have to figure out our blocking, our joist hangers, nails for our sheeting, and our adhesive. So our framing nails, basically we figure for every 6 joists, we're going to use 1 pound of nails. So in this example here, if we've got an I joist that's running all the way through, that's going to be 20 joists. So we're going to need, if we take 20 divided by 6, that ends up being 3.3. We round that up to 4 pounds. If we go 40 joist, because we're going to have the joist on one side of the beam and then the joist on the other side of the beam, and again we're going to have more nails because we're going to have to fasten on both ends, because essentially what we're doing is we're just fastening at the ends. So in that case there, we're going to have 40 joist. So if it's 6 joists per pound of nails, that's going to end up being 6.67, which we round up to 7 pounds of nails for those 40 joists. So let's talk about blocking next. So our blocking is going to be at the midspan of each joist. So there's 21 joist spaces. So if we're going, we are going to have that blocking basically going on each side of that center column is the span. So we've got 2 spans for each set of joist. And if you notice here, I had 20 joists, but I have 21 joist spaces because the blocking is going in the spaces. So in this case here, since we've got the 21 joist spaces, I'm going to run a set of blocking down the midspan of joist 1 and then down the midspan of joist 2, which would be 42 blocks. Now, let's assume that if we were going to go with joist hangers, and let's say that this center beam is flush and we're going to butt up into that. So basically what we're going to do is we're going to have one joist hanger for each joist, essentially. So we're going to have the joist number 1 and the joist number 2. So in this case here, we're going to have 40, we'll end up having 40 hangers. Our sheeting nails, we're figuring that 3/4 pounds of nails per sheet. So in this example here, what I figured out before was the 23 sheets, and I would include that overage in that number. So we're going to take that 23 sheets times 0.75, which ends up being 17.25, or we round up to 18 pounds. And then the last thing that we figure out is our adhesive. So our adhesive is going to go on every joist. It's going to go on the top of every joist, and it's going to go on top of the rim board also. So in this case here, we've got 20 joists that are 24 feet long, which is 480 foot of joist, and we've got 104 feet of rim board that go around the perimeter. So we add those together, we've got 584 lineal feet of joist. So if we take that and divide that by 48 foot, that ends up being 12.16 or 13 tubes of adhesive for this floor system. And again, I just want to kind of go over this too, because this is basically, if we're going to do a spreadsheet of all of the components that would be a part of this would be all of the things that we would end up figuring out. So that's the lecture for today. Thank you very much.